Question 25 is testing your knowledge of if you know a number is rational or irrational. So in this question, it's asking you if the sum of 4.2, 4 and 2 tenths, and the square root of 2 is rational or irrational. And Patrick answered irrational. So the first thing that you need to say is whether or not Patrick is correct or incorrect. Let's first show the sum. So we're adding 4.2 and the square root of 2, and that comes out to be approximately 5.6. And as you can see, this decimal does not end and it does not repeat. And the reason that it does not end or repeat is because of the square root of 2 here. So we know that this number here is irrational, so Patrick is correct. So here's an explanation. Patrick is correct. You have to say something about this. And the sum of 4.2 and the square root of 2 is irrational because it is a number that does not end and does not repeat. That would be plenty enough information to get you the full 2 points. You can also get information or get the full 2 points by leaving the information Patrick is correct. The sum of 4.2 and square root of 2 is irrational because it cannot be written as a fraction. Question 26 is asking us if there are 180 students in 9th grade, what percentage of the 9th grade students belong to more than one club? So if we look at our chart, we're going to look at the 9th grade students, which is here, and more than one club would mean 2 clubs or 3 clubs or more. Now you might recognize that if you add 90, 33, and 12 together, that you do not get 180 because it's possible that students don't belong to any clubs. So what we need to do is focus on the 33 and the 12, and if we add those two together, 33 plus 12, we end up with 45. So we have a total of 45 out of 180 students that belong to more than one club. And if we don't write this as a percent, then we don't get full credit. So let's divide this out on our calculator and write as a percent. And 45 divided by 180 is equal to 25 hundredths, which is 25%. Number 27 is testing the definition of a function. So we need to figure out which of the 2 points, when added to this table, would create something that's not a function. So we are looking for the x values to repeat, which would make it not a function because every x has to have only one y. So -4 can only go to 2. So if we add -4, 1 to the table, -4 would go to 2 and -4 would also map to 1. My recommendation, if you miss this question, is graph it. Show a picture. Many of you know that the vertical line test would be a good way to show whether or not it is or is not a function. But remember, in your explanation, you need to talk something about every input has to have only one output, or the x value of -4 would have 2 different y values. Remember, inputs are x, outputs are y. I'm hoping that all of you made me proud in question 28 and used parentheses. If you didn't, you probably missed some points here or got the whole question wrong. So we need to subtract this from this. So that means we start with the 3x squared plus 8x minus 7 and take away the 5x squared plus 2x minus 11. Now the parentheses are so important because this negative must be distributed to all of the 3 terms. And lastly, group together your like terms. So your final answer should be -2x squared plus 6x plus 4. Question 29. It's important to first identify what type of equation this is because it says to solve. So when we solve, we have 2 options, plan A and plan B. Linear versus quadratic. Linear, we get the x's alone or the variable alone on one side, and the quadratic, we have to set it equal to 0. I'm hoping that all of you know, because of that x squared here, that we are looking at a quadratic. So let's move the 7 to the other side to set this whole quadratic equal to 0. Next, I'm going to graph this so I can see what type of roots I'm looking at here. Are they rational or irrational? That will help guide me to know whether or not to solve maybe by factoring or completing the square or maybe the quadratic formula. So when I found my roots on my calculator, I ended up with -1/2 and 7/2, which tells me that my roots are integers, so this can be factored. Now, this isn't the only method. Some of you might say, you know what, because they're fractions that I don't really want to go that way and I want to use a quadratic formula, but this can be factored. So I'm going to actually go with the quadratic formula because I think that most of you at this point would say that the guess and check method is a little bit more difficult. So first identify what A, B, and C are, and then write down the quadratic formula from your reference sheet. Next, substitute your A, B, and your C into the formula and use parentheses. Notice how that this is a -12, so always be careful. The next step, we need to simplify each one of these three pieces. This piece, underneath the square root, and the denominator. Next, I'm going to take the square root of 256 because it is a perfect square. Then I'm going to divide 8 into 12 and 8 into 16. So I end up with two problems. X is equal to 1.5 plus 2 and x is equal to 1.5 minus 2. So when I go ahead and calculate that, I end up with x is equal to 3.5 and -1/2, which of course is the same as what we found up above here. Just up top, our calculator wrote them as fractions, and it's definitely okay if you had those as 7/2 and -1/2. In question 30, we have a piecewise function, which means we're piecing together two different functions. So the things that we have to be aware of when we have a piecewise function are their intervals. So we have, in this case, two functions that are being pieced together. If we had another row, we would have had three functions pieced together. So what I like to do is I like to set up both of my functions and a table of values directly underneath them. So my first function is the absolute value of x, and we're going to set up a table of values underneath. And we are going from the x values from -3 all the way to +1. Now we're not going to talk about the open and closed points just yet, but we will when we begin graphing. I also have the function f of x equals 4, and that is from 1 all the way until 8. So the nice part about this function is when you put in 1, 2, 3, 4, 5, 6, 7, 8, anything, we are only going to get out the value of 4. So I'm just going to put all of the outputs as 4. Remember, these are the input values, and this is how we find the output values. Okay, so now going back, let's finish off the table for the absolute value of x. We're trying to find the absolute value of -3, which is just 3. You can use your calculator, it's in the key of everything, or if you just know the absolute value of a number makes it positive or keeps it positive, you can just do that as well. So this would be 3, 2, 1, 0, and 1. So my next step is going to plot all of these points. So I'm going to plot the point -3, 3, -2, 2, -1, 1, 0, 0. Now I need to be careful with my point of 1, 1 because it is not equal to. So that indicates that I have an open point. Okay, so I can connect these together. Oops. Let's try that again. Using a straight line. And I also need to now plot my second part. So what I've done here is I've plotted 4 of the points. I could plot more. I just think that sometimes it looks a little messy on the Smart notebook, and it's not as easy to plot the points, seeing as I already have that one that's a little higher, but this now would complete our function. And just a quick reminder, we're looking at our intervals up here. Our function, the absolute value of x, begins at -3, so it's a closed point because it's less than or equal to, and it goes to an open point because it's only less than 1. Our second part of the function, 4, is going to begin at 1 and go all the way to 8, and both of those points are closed because they're both less than or equal to. Question 31 is talking about a gardener, and he's planting two different types of trees, type A and type B. And we can see that they both have some differences. And the one thing that I'm noticing right away is that this is in feet and this is in inches. So right away I know that I'm going to have to do some type of conversion when I'm creating my problem. So it says below, algebraically determine how many years it will take for these trees to be the same height. So I know in math that the word the same means equal. So we want the two heights to be equal. So I want A to equal B. So I need to write type A in math lingo. So type A is 3 feet tall. So if type A is 3 feet tall, how many inches is that? Well, since there's 12 inches in a foot, I'll just simply multiply 3 times 12 to get me 36. So I know that type A is originally 36, aka 3 feet tall, and grows, so it's going to increase at a rate of 15 inches per year. And I'm going to say Y is years. I should have put that first, just because I always tell you guys to define your variable at the beginning, so let's not forget to do that. And that equals, type B is 4 feet tall. Well, 4 feet in terms of inches is 4 times 12. So 4 times 12 is 48. This one starts off a little bigger and grows at a slower rate of 10 inches per year. So now I have an equation. A equals B. Type A equals type B, and I need to figure out what Y is. Since this is not a quadratic equation, I can simply resort to my sorting method to solve for Y. So 15Y minus 10Y is equal to 48 minus 36. I just moved my variables to the left side and my constants to the right. So 36 became negative and 10Y became negative. Then I'm just going to simply keep going and get 5Y is equal to 12, and divide both sides by 5. So Y is 2 4/10 years. Question number 2 wants us to find the equation, and it even tells us it's an exponential equation. So we know it's going to take the form y is equal to a times b to the x power, possibly plus or minus something on the outside, but usually they take this form. So there's a few different ways that we could come up with the answer to this, but what I think is probably the easiest is either one, typing in all of the points into a table on your calculator. So we're going to use the points that are really easy to identify. Okay, so like these 3 there, and come up with a linear regression. Or if you know what the parent function looks like, this could be very easy. So if you remember, the parent function passes through the point 0, 1 as the y-intercept. So let's actually write this in pink. Oh, that was supposed to be pink. There we go. So 0, 1, and remember our parent function is y equals 2 to the x power. So if we put in 0, we end up getting 1 out. If we put in 1, we would end up getting 2 out. If we put in 2, we would end up getting 4 out. Ooh, that one was a little high. Let's see if I can get that a little bit better. So as you can see, and I am missing a point on my black line here, all 3 of those points actually line up very nicely with the black points, only they're actually 2 units to the left of it. So if we start with our parent function, we can see that the parent function has actually been moved over 2 spaces to the right. So here's our parent function, and we can see that all of those points are moved over 2 spaces to the right. So let's remember how to write this. Y is equal to 2 to the x minus 2. because when we shift left or right, it always goes inside the parentheses. So this is one way of doing it, and I'm going to explain this process. But if you came up with something else that was a little bit different, so there was actually another equation that you could have gotten for this. We'll talk about that in just a moment. So let me just type up a little blurb of what would be an acceptable answer of all this work that I just explained above. Okay, so really all you had to say was that the parent function was shifted 2 units to the right. Now, if you had done this question on your calculator, you actually would not have gotten in this equation, you would have gotten y is equal to 0.25 all times 2 to the x power, which is also correct. But your explanation would have said something like, I used my calculator and found an exponential regression, and my calculator told me that this was the equation. You might even want to go a little bit farther and say that you know that this makes sense because the 0.25 is always my y-intercept, which happens to be right down here. So there's a couple of things that you could have said or done on this question, and if you're unsure of how to give yourself 2, 1, or 0 points, make sure to ask. Question number 3 is about Jacob and Zachary going to the movie theater, and they're buying refreshments for their friends. So Jacob spends a total of $18.25 on 2 bags of popcorn and 3 drinks, and Zach spends a total of $27.50 on 4 bags of popcorn and 2 drinks. So right away, I'm hoping that you guys are thinking, hey, wait a second. There's some information here that I don't know. And if you read on, it says we need to write a system of equations that can be used to find the price of 1 bag of popcorn and the price of 1 drink. So I don't know the price of a bag of popcorn, and I don't know the price of a drink. So immediately, we are going to bring in some variables. P is going to equal the cost of 1 popcorn and let's say D is the cost of 1 drink. So I always have to do this. Whenever I see a word problem and I'm trying to find things that are missing, I need to identify and give the things that are missing variables. So if I look above, we haven't written a system yet. We've just said what we don't know. So a system is 2 equations. So a system of equations, I need to create 2 equations. And we're going to get that from up above. So here we see that Jacob spends a total of $18.25 on 2 bags of popcorn and 3 drinks. So, we know 2 bags of popcorn, 2P, plus 3 drinks is equal to $18.25. There's one equation. We also know that Zachary spends $27.50 on 4 bags of popcorn and 2 drinks. So I'm hoping that everyone got to this point. This should have been a pretty straightforward question in terms of translating. So we now have a system of equations. We don't have to do anything with it yet, but if we read on, it says down below that we need to use these equations. We have to figure out what P and D actually are. So I'm just going to almost copy and paste those 2 equations down below. Okay, so I need to solve equations, and we have to solve them algebraically. We need to show all of our work. Some of you might want to try graphing these, but it would be quite difficult because we don't have y equals mx plus b form. We could, that's not an issue. So we have 2 ways to solve a system. I'm hoping that you guys pulled this from your Unit 3 linear equations unit, or linear functions. We can solve systems either algebraically by substitution or elimination. And elimination looks like it's going to be my winner. So elimination is exactly what it sounds like. We need to eliminate one of the variables. Now, right now, if I add my equations or subtract them, I'm not going to get either variable to cancel because 4 minus 2 is still 2, 3 minus 2 is still 1. I need the additive inverse to happen somewhere. And if it doesn't happen, I need to force it to happen. So I'm going to choose to multiply my entire equation above by -2 because if I do that, I'm going to get a negative 4p, which will help me get that additive inverse. So let's go ahead and multiply our first equation by -2. Okay, so as you look to the right, you can see that I copied both of these two equations down. So now what we're going to do is we're actually going to look at this stuff vertically. I'm going to add these two together because a negative 4p plus 4p is 0p. So the p terms disappear. So then I'm left with negative 4d equals -9. Negative $36.50 plus $27.50 is equal to -9. Now it's smooth sailing from here on out. We just need to divide both sides by -4. So if we do that, we end up getting D, the cost of a drink, being $2.25. So here is part of my question. Now, some of you might think, oh, wow, do I have to do that all over again to find the cost of a bag of popcorn? And the answer is actually no. We can use substitution to help us. So this is going to bring me back to one of my original equations that I wrote. And it doesn't matter which one you use. So I like to keep it simple. Both of these, not bad. So I'm just going to use the first one. 2p plus 3d is equal to $18.25. So I know that d now is $2.25. So what I'm going to do is I'm going to replace d with that $2.25 so I can figure out my missing variable of p. So if I just keep going and simplify 2p, and I simplify 3 times $2.25, I get $6.75 equals $18.25. I'm going to continue solving, so I'm going to take away that 675 from, or excuse me, 675 from 1825. Basically move this term, move this term to the other side. I get 2p is equal to $11.50. Last but not least, divide both sides by 2. And I get my final answer as p, a bag of popcorn, equaling $5.75. So I'm going to make sure that I have my units on there, which I do. Dollars and dollars. And because up top, this is a cool part, because what I said up here, and I said P is the cost of one popcorn and D is the cost of one drink, I don't have to write a sentence because I already said what they were up above. So defining your variables is really important because it saves you some time having to write sentences at the end. All right, so moving on, the graph of an inequality is shown below. So part A, in question number 34, wants us to write the inequality represented by this graph. Well, the first thing that I'm hoping that many of you wrote down, and I know that we're looking for an inequality, but we know the general form of an equation is y equals mx plus b. So our equation, we're going to try, or in this case, an inequality, we're going to try to model it to make it look like the slope-intercept form. So we need the slope and we need the y-intercept. So let's look up at our graph. Well, here's our y-intercept. So our y-intercept is -3, and our slope, remember, is rise over run. So up to the right 1. Oops, plus 1. So our m is equal to 2 over 1, which we in our equation are just going to use the number 2. So there's a couple other things that we need to talk about with this. Y is not equal to anymore. We need to determine, is it greater than, less than, greater than or equal to, or less than or equal to. The first thing I notice is that our graph is shaded above the line. So we know it's a greater than symbol. Now I'm going to look and see, is my line solid or dashed? It's solid, which means it can equal that line. So greater than or equal to. My m is 2, so 2x minus 3. Okay, so moving on, what we are going to do is we have to graph the inequality on the set of axes above. So basically, I have that +2, +1 kind of hanging up here, and I want you to erase that if you have that on your graph. I just can't erase it. My program won't let me. So what we need to do is we need to graph x plus 2y is less than 4. And in order to do this, we have to get our inequality in slope-intercept form. So I'm going to move the x to the other side. So I'll first get 2y is less than -x plus 4. Notice how I wrote the x term first, even though I could have written it as y minus x. And then we're going to divide everything by 2. Squeeze it in there. And when I do that, I'm just going to write this off to the side where I have room. Y is less than -1/2 x plus 2. So up in pink, I'm going to graph this line. Okay, there is the y-intercept at 2, and then my slope is -1/2. So down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. Or I could go up 1 to the left 2, same difference. Now some of you might have gotten your line going in the opposite direction, and that's because your slope should be negative and not positive, so just be careful. Then we are going to connect our points with a dashed line because we know that it can't equal y, and we also need to shade below because it is less than. We have a less than symbol, so less than means shade below. Another good quality that we can put on our graph is a big S in the solution where the two sections overlap, which actually leads us to part C. It says the two inequalities graph together form a system, and Oscar thinks that the point 2, 1, so let's actually plot that point 2, 1 on the graph, which is the intersection point here. And we need to think, is this a solution? Is this going to solve both of these inequalities? And I'm hoping that you said that the answer is no. So let's talk about why. All of these points in here are a solution. However, on a solid line, it is a solution. So some of you might be thinking, well, wait a second, it's on a solid line. However, our second inequality indicates that it is not part of a solution because the line is dashed. So let's type that up and summarize that into a little blurb down below. Okay, so what we've written below is that we say that Oscar is incorrect. Remember to always answer the question. And let's explain. The point 2, 1 is not a solution because it does not make the inequality, the second one that we graphed, true. So I used a little algebra to help support my claim. I put in the point 2, 1 into the inequality that I'm saying is causing this not to be a solution, and you end up with 4 is less than 4, which is not a true statement. 4 equals 4, 4 is not less than 4. So in question number 35, we're given a ton of data, and we are asked to find the correlation coefficient for the line of best fit. So whether or not you agree or disagree that this should be linear or exponential or quadratic, they want you to find the line. So we have to do a linear regression. I'm hoping that all of you got this question right because we've done a lot of practice with linear regressions lately. So if you typed this all into your calculator, you should have ended up with 0.94. Remember, we needed to round to the nearest hundredth. So be careful of rounding. Don't make a silly rounding mistake. These are easy points that you should definitely get on the test. So we should have 94 hundredths. So part B then says explain what the correlation coefficient tells us really about this problem. So what it tells us is, well, we like this number. So what it says is that this line is a good model because it shows the relationship that we have found in this model that we created between the calories and the sodium in a beef hot dog to have a relationship with one another that can be basically predicted over time. So let's write that up in a little bit more of a couple sentences or two to keep it nice, short, and sweet. Okay, so let's read what I've written down below. The correlation coefficient, what does it tell us? Well, it tells us that the line of best fit that we found is a good model for our data. It shows that as the calories increase, so does the sodium, or so do the milligrams of sodium. So you just used this correlation coefficient after you typed everything in your calculator. Remember, you will not have those directions on the Regents exam, so you need to make sure that you memorize them if you did happen to use your study guide to help you. Question number 36 gives us a parabola and wants to really ask us if the vertex is a maximum or a minimum. So this is really simple if you know how parabolas work. So the vertex is a maximum because the leading coefficient is negative. And what does this mean? Well, this means the parabola is concave down. Okay, so remember the leading coefficient is the number in front of the x squared. So part B now wants us to rewrite in vertex form. Well, let's first copy and paste our original. And already, I'm not totally digging this because of that negative, because it means that I have to do a little bit more work, but it's nothing too crazy. Remember, the first thing that we'll do is factor out the negative that's in front of the x squared from the first two terms only. Because that 9, that plus 9, he's an afterthought that we talk about at the end. Okay, next, I need to now complete the square of this piece here. So what I'm trying to do, remember, when I complete the square, and definitely do not forget that negative out in front, is I want two numbers to add to -8 that are the same exact number and multiply to, well, lucky us, we get to pick it. So we do this by taking half of -8, which is -4. And since -4 times -4 is positive 16, I'm going to add 16 right in here. However, be very careful because technically we didn't add 16, we subtracted it because of this negative, that tricky negative out in front. So in order to cancel out subtracting 16, we have to add it. So it almost looks like we're adding 16, and some of you are like, no, that's wrong. But remember, this negative throws us off a little bit. So next, add the 16 and the 9 together to get positive 25. And our last and final step is to write in vertex form. So we group together my x minus 4 all squared plus 25. So question number 37 basically is talking about gardens being renovated. And one garden in particular that was originally a square. So right away, I know I'm drawing a picture of a square. And it says that the garden is going to be adjusted so that one of the sides changes. It's going to be doubled in length, while the other side is decreased by 3 meters. So it looks like I'm going to have to draw not a square, but a rectangle, because my side lengths are changing. So let's draw a picture of a rectangle right next to it. I don't know why it's not letting me do this. Let's try that again. Here we go. So here's our rectangle. So one thing that I do know is what I don't know. I don't know any of these side lengths. They don't say that anywhere, not even down below in the other parts to the problem. So I'm going to go ahead and bring in my variable. This is my let statement. It's a square. So if I don't know this side, I don't know that side, they're both x. I do know that one side is doubled in length, so 2x. And the other side is decreased by 3 meters. So got a little smaller. My picture doesn't necessarily reflect that, but we're just going to label it with x minus 3, even though it looks about the same. Okay, so you might want to label these old and new, just so we don't get them confused. And what it does say is that in the next part, the new rectangular garden will have an area. Well, wait a minute. It didn't talk anything about area yet, so maybe we want to go ahead and find the area. The area would be length times width. Remember, this is the formula that we always know. Area is equal to length times width. So x times x would be x squared. Now in my new garden, this one's a little trickier, but nothing terrible. 2x times x minus 3, which is really 2x squared minus 6x. So I have my old garden area and my new garden area. So let's keep reading on. The new rectangular garden will have an area that is, okay, so the new rectangular garden, so the area of that, 2x squared minus 6x, will have an area that is means equals 25% more than the original square garden. Well, let's relate this back to our exponential unit when we were talking about exponential growth and decay. If the area stayed the same, it would stay 100% of the original area. But in this case, it's actually increasing by 25%. So we're really looking at 125%, which we write as 1.25. But we don't write it as 1.25. That would mean 1.25 square meters. What unit are we looking at? Yeah, meters. And that's not the case. We want this to really represent 125% of something. So looks like it's of the original square gardens area. So that would be 1.25 times. Remember, of means multiply. So times x squared. So here is the equation. Believe it or not, there's going to be a little decimal in there. And down below, we need to explain how we got that. So I'm just going to take a minute to explain everything that we just did up above. Okay, so what we have written down here is that the new garden has an area of 2x squared minus 6x. Since this is 125% more than the original garden's area, I multiplied the original area of x squared by 1.25 and set the two equal to one another. So kind of ignore the mess. Something happened when I was moving the page around up above. So down below here, it now says determine the area of the new rectangular garden. So I rewrote the equation that I came up with in the first part, and we need to solve this. So right away, I see an x squared. This is not a normal equation, this is a quadratic equation. So what we need to do is we need to figure out what x squared actually is. So in order to do that, you set the whole thing equal to 0. So we're going to move the 1.25 x squared to the other side, and when we do that, we get 0.75x squared minus 6x is equal to 0. And if we continue to solve this, we can either use a quadratic equation or we could factor. I'm actually going to try something a little strange and factor out a 0.75, and of course we can factor out an x, just to see if this can actually be factored nicely. Of course, I'm just left with an x after I divide out the 0.75, and 6 divided by 0.75 is actually 8, so x minus 8. See where we're going with this? So now what we want to do is take each of our two factors, 0.75x, set that one equal to 0, so we get x is equal to 0, which we don't want this answer because we don't want anything in terms of dimensions to be 0, then the problem doesn't make sense. So let's hope the other one of x minus 8 does. Oh, this one here is x is equal to a positive 8. So, did we answer the question? The area of the new rectangular garden? No, we didn't yet. We know what x is, but we do know that the new rectangular garden's area is this right here. So if we take that 8, 2 times 8 squared minus 6 times 8, and substitute everything in, we find the area, final answer, is 80 meters squared.